So you want to build on Polkadot. How do you get started? What are the different pathways? There's a few pathways and there's trade-offs to each one. The most obvious one is building a blockchain on Polkadot, building a blockchain that's connected to Polkadot, which we call a parachain. So the trade-offs there is like on the pro side, you are building a blockchain that inherits the Polkadot multi-billion dollar security, and you're building a blockchain, right? So that means you have low level control of the Web3 protocol that you're building. Whereas the cons, I would say, is that there's a huge learning curve. It's not the easiest thing to build a blockchain. It's not the easiest thing to maintain a blockchain. There's a lot of knowledge that's required to do so. And that's something that you or your team would have to decide. So if you are interested in learning how to build a blockchain with Polkadot, you can go to the polkadot.com website. There's a call to action, start building, and there's excellent Polkadot documentation on how you can get started building a parachain with Polkadot, the Polkadot SDK. All right. So that's there for you. The other way that you can get started building stuff on Polkadot is if you say, let's say you have some JavaScript background, like a lot of developers, right, are JavaScript fluent. Well, we have an excellent Polkadot JavaScript library called Pappy, Polkadot API. It's a TypeScript API to interact with existing Polkadot chains. So interacting with Polkadot chains that are already live, if you want to build dApps around them, Pappy is an excellent library to build that. And the website is Pappy, here it is, pappy.how. So pappy.how, here's the website, and you can read over the features and excellent documentation that you can go through as well as examples. So what if you have a Web3 idea and you know what you want to build and you just want to like test it for market fit, right? Like you don't have the time or the resources to build a full-blown blockchain, and also maybe you don't need one to test this idea out. Maybe you've even tested this idea out in other ecosystems via smart contracts. Can you do this on Polkadot? Yes, you can. So there's now a Solidity team within Parity Technologies, the company who built Polkadot, and they're working on this. You can now start launching, deploying Solidity smart contracts natively on Polkadot. And that's done by deploying it to the parachain that we call Asset Hub. Asset Hub is the parachain, the Polkadot system parachain that has functionality around assets, fungibles and non-fungibles. And so the plan is to integrate smart contracts, Solidity smart contract functionality into Asset Hub. So right now it's experimental. It's already been launched on Asset Hub on the West End. West End is the test network for Polkadot, and it's working. I'll show that to you today. And in end of Q1 or sometime during Q2, it's planned to launch this functionality to deploy Solidity smart contract natively uh, on Polkadot on Kusama. Kusama is the sibling to Polkadot. It's the test network with real economic value. So that'll be an exciting day. So this is the time to get started with Solidity on Polkadot, because by the time like uh, you get your your feet warmed up with Solidity on Polkadot, it's already going to be available in production. So let's talk about the underlying technology that makes Solidity on Polkadot available natively, right? So to what degree do I mean natively? Well, it's actually to the degree that we have Solidity running not on EVM, not on the Ethereum virtual machine. Uh, Polkadot is creating the Polkadot community, key people in the community. Uh, we're creating a Polkadot virtual machine. It's called PolkaVM, PVM for short, and it's super fast and it's faster than EVM. And that's what you'll be able to run your Solidity smart contracts on. It's pretty amazing. And what's going to allow that to be done on, like, let's say, Asset Hub, right? Asset Hub, for those of you who are familiar, it's built with the Substrate blockchain Rust framework, right? So all the parachains are built with the Substrate framework. And the Substrate framework consists of the node, or you can call it the client, right, that runs the blockchain. And then it consists of the business logic, which we call the runtime. So in that runtime, there's a special module, Rust module called Palette Revive that the Solidity team in Parity is working on, and it's actually a fork of the already existing heavily audited contracts module that exists, the contracts palette that has been functioning already for WebAssembly smart contracts, and it's an excellent module. So the Solidity team at Parity, they forked this and they began to work on integrating that PVM functionality that I've been talking about into Palette Revive. So the idea is that Palette Revive provides all the functionality for that substrate runtime to for you to deploy and execute these lightning fast PVM Solidity smart contracts, right? So the other aspect of this like Solidity solution, which we could it's called the Revive project. The other aspect that goes along with this palette is an Ethereum JSON RPC server. So this was strategically chosen architecturally, like by design, because we want the Polkadot community wants to make uh, it transparent for you to for existing tooling, you could say that the existing Ethereum ecosystem to play with Polkadot with Solidity and not even notice that it's Polkadot, that type of transparency. So that's possible with this Ethereum JSON RPC server. So it exists like a proxy so that the external world can interact with this RPC proxy server as if it's talking to Ethereum, right? But under the hood, it's got like that blazing fast, like PVM stuff that's happening with Palette Revive. So it says here block explorers, they can read from this ethrpc server, right? So like, they can't really tell the difference. And Revive does a lot of that hidden magic, including because it's substrate, we got substrate accounts under the hood, but it does the eth address to substrate account mapping, right? So that you can use metamask and interact with Solidity on Polkadot. So the way that it would work would be that uh, wallets would use this ethrpc server, connect to it, and the user could interact and send transactions to a Solidity smart contract, deploy a Solidity smart contract, call a Solidity smart contract, and such. So at the end of the day, this ethrpc server, it will actually like submit the transaction to Palette Revive as a client. And when it submits the ETH transaction to Palette Revive, it keeps the ETH payload intact, untouched, so that the existing tooling such as block explorers and such, they can just read the block, and it just makes sense to them. There's no different transaction format. So those of you who have a coding background, I want to actually show you a little bit of the source code. For those of you who don't just don't get intimidated by this. But like here's the Polkadot SDK, right? Like I'm pulling it up. This is the Polkadot SDK, and inside of it, it's got the Substrate blockchain framework, written in Rust. And if you scroll down, it's got Frame. It's like the framework within the frame is like the framework within the substrate framework. It's the framework within the framework. The framework within the blockchain framework. It's the framework to build runtimes you can think of. It's all like the business logic. Like each one of these is what we call a palette. These are like the Lego building blocks for like business logic to construct your blockchain's runtime, right? So, like I said, there is a contracts palette right there, contracts, and that's what the Solidity team in Parity, they forked this and they created Palette Revive. So Palette Revive is right there, Revive. So if we go inside of that folder, here's all the source code for Palette Revive, along with some description in the README. And what I want to point out here is that you can see there's a folder here, RPC. This is actually the ETH RPC proxy server that I was talking about. And if we look at the source code, it's available, right? It's open source. We can actually dip into this like CLI. Let's look at the CLI here. So here's the CLI. Okay. So we could actually look at the CLI. And if I wanted to look at the actual source code, I could go to librs, let's say. And there it is, RPC server implementation. And we can scroll down and look at all the source code that's available there, right? So at the end of this day, the way that this connects to this ETH RPC server connects to the Palette Revive is as a client. So let me show you that. I believe that we can get that. I believe that's in the, let's see here. If we poke around APIs client, let's look at that one. I believe it's in here. Client, here it is. The client connects to the source substrate chain and is used by the RPC server to query and send transactions to the substrate chain. So you can see we're importing the create subxt client, right? And if we scroll down, palette revive, and if we scroll down further, we can see, I want to show you here the struct. So where's the struct, the client struct? So here's where we define the client struct. And I also want to show you where we implement the client here. That's pretty cool. So we can create a new client to connect, right? And we subscribe to Palette Revive's runtime API. Let's see, there should be a function down here. Storage API. So yeah, we get the storage API, runtime API, expose the runtime API. And what's interesting is it'll return the API. Okay. So then down here, when we want to submit, expose the transaction API, submit, you can see that it's saying dot API, dot transaction, create unsigned, and it's submitting the call. And we can see the call is passed in as an argument, and there's an ETH transaction, right? So that's how the ETH RPC server is subscribing as a client and submitting the transaction to Palette Revive. So if we go back, let's go back here. And you can see here it says ETH RPC server repackages the ETH transaction into a dispatchable suitable for Palette Revive. Okay, so the ETH RPC server is essentially an interface to the external world. It's what the external world interacts with. All right, so I hope that made a little bit more sense. Solidity smart contracts on Polkadot run on the blazingly fast RISC-V based PVM, not the stack-based EVM, right? So I'll talk a little bit about that. Like if we go here, let me go here. Yep, PVM compilation. So PVM is a RISC-V embedded instruction set architecture, ISA. It's really fast, mostly because it's really close to bare metal. So the ISA passes arguments in a finite set of registers versus, a stack, EVM stack. Therefore, the translation step to the underlying hardware is more efficient, as the underlying hardware is a register machine as well. So ISA is closer to the hardware slash, the CPU. Therefore, you get faster execution and compilation times. The PVM was it was a breakthrough that the Polkadot community stumbled upon, and it's also the workhorse behind Jam, right? Jam is the new Polkadot protocol that Gavin team are working on, and it's going to be what's going to be powering the Jam services. So Palette Revive uses the PVM as an interpreter. There's a PVM interpreter within the runtime, but it's planned on the roadmap to include PVM JIT available from the node as well. But it'll always be available as an interpreter from the runtime because there's certain you could say logic that would just be quicker, faster, just going through the interpreter versus going through the node. So if we go back here, uh, as a recap, Palette Revive provides functionality for the blockchain to deploy and execute PVM smart contracts. So it can go beyond Solidity, right? It can go actually anything that can adhere to Palette Revive's API. So if one wanted to extend it to a different programming language and have other programming languages work with the Palette Revive APIs, you can do that and it'll run it with PVM, right? It's got to compile down to PVM essentially. So you could technically have Rust compile down, write like a Rust logic, business logic, and have it compile down to PVM and submit it to Palette Revive, and it'll run that. So there is an example code out there. You can take a look. So at the end of the day, Palette Revive has APIs for smart contract to blockchain interaction. And it also provides smart contract storage, sandboxing, and limits for the smart contract, right? So smart contract is limited in what it can do because it is untrusted code at the end of the day. So going back to that idea of like testing your Web3 idea out, if you can test it via smart contract uh, on Polkadot, then do that. But if you need to go beyond the sandboxing limits, then that's where it may make sense to build your own blockchain, build your own substrate blockchain, so that you can have full access of the blockchain, whether it's like the node level or runtime or whatever it may be that you're impeded with as a smart contract on Polkadot. So I have a little question here. Why not build the ETH RPC server as part of like the substrate node, right? As part of the blockchain's node? And there was a design decision that's like instead of modifying the substrate node uh, and including those RPC endpoints, the substrate node is built in a generic way where uh, not all teams are going to have Solidity functionality in their blockchain, in their pair chain, right? Or in their sovereign solo chain. So there was a decision that was made like, okay, we don't need to include that as the node because otherwise, like everyone would have to, inherit that functionality, even if they use or don't use the Solidity smart contracts. So for now, it's an independent RPC node, which works fine. But it isn't to say that in the future things may change. I believe like there's a project out there called Data Haven, same people that built Moonbeam, and I was looking at their specs. They released their light paper, and in one of their diagrams, it does show that they have the an ETH uh, as part of their node. I didn't confirm this because I didn't see their source code, but they may have done that. So because with Substrate, right? Substrate is built in a generic manner where you can customize the runtime. You can also customize the node. The node is there's a bit more learning curve to customize the node versus the runtime. But you could absolutely do that, and you could include the ETHRPC as part of the node. So what's on the roadmap as well? So another good reason to, if you're entering Polkadot right now, to enter via the Solidity pathway is because there's going to be these pre-compiles which will allow for synchronous composability. So previously with Polkadot, if you were deploying logic on a parachain and you wanted to access, like for example, staking or functionality from other parachains, you'd have to build a cross-chain solution. And so uh, Parity and the Solidity team, they announced recently, actually it's in this YouTube video here. You can see excellent video. I recommend you watch it. It has to do with Solidity on Polkadot. And this is Cyril, software engineer, blockchain engineer, part of the Revive team, the Solidity team on Parity. And he talks about this, about the fact that there's still a lot of functionality on the Polkadot relay chain, such as staking, governance, and things like that, that were never meant to be on the relay chain. But because Parity wanted to hit the ground running, and testing the proof of concept for Polkadot, it just became part of the Polkadot relay chain. So now that Polkadot has matured, it's like, okay, let's get some of that functionality that doesn't belong on the relay chain. The relay chain, just there for relaying messages, providing security to the network. Beyond that, all other features that should be abstracted out to other parachains or even one parachain. So the idea now is that a lot of that functionality is going to go into the Asset Hub parachain. Functionality such as staking, assets already exist on there, right? Asset Hub parachain. So you can interact with existing assets, fungible and non-fungible. You can also create new assets. So things like treasury, referenda, balances. So these will exist on the runtime level, right? Because these are all like palettes. So if we go back into the Polkadot SDK, if I click in here and I scroll down, substrate, where's substrate folder, frame, the framework within the framework. And you can see like there's assets palette, right? And all these additional asset conversion, right? So there's all these palettes. What's the other one? Treasury we saw. Where's Treasury? Treasury is down here. Treasury, right here. Treasury, right? So all these they exist as like either one palette or multiple palettes, and so the runtime level type of functionality. And so how can a Solidity smart contract access that stuff once it becomes available on Asset Hub? Well, it'll access it via the precompiles that the Solidity team and Parity are building. They're building these precompiles so that you can build really powerful Solidity smart contracts that interact with existing powerful Polkadot features, right? And it's all going to be on one pair chain, therefore synchronous composability. So another great like reason to start out with Solidity on Polkadot if you're thinking like where should I start? Okay. So this one I covered PVM, how amazing it's going to be really it's a game changer. It's the power horse of the Jam protocol, and also another reason for you to get started with Solidity on Polkadot. So you start, testing your solution with Solidity, and you get your feet wet with Solidity, so that you start learning about the Polkadot tech, the Polkadot uh, all the Polkadot, like how the Polkadot ecosystem works, right? And you start already investing your development in PVM by going with the Solidity route. Um, and then when Jam starts maturing, when we start actually being able to build production services, you can transition from Solidity, PVM Solidity to Jam services. So this is already promising. Like there was a tweet the other day, I think I have it here somewhere. Is it here? I have it. Jam. Where's the tweet? Here. So Gav tweeted. Gav's right. He created the Solidity programming language, and he's the founder of Polkadot. Created the white paper for Polkadot. Um, he's now working on this Jam protocol. And if I make it larger, this was him showing off a little prototype. Let's see. So you can see here. This is Jam, right? So it's like a prototype, and it looks like he's kicking off a service, and so this is promising, right? This is happening now. This is there's several teams working on different implementations of the Jam protocol, so this is coming. So start now, start with Solidity, so that you can you're ready for Jam. Okay, so. Hopefully, everything that I discussed made sense. A different way that we can look at it is looking at this diagram. So this diagram shows you the compilation steps involved in compiling like a Solidity PVM smart contract. And the way that you do it, you'd use an IDE like Remix. However, you'd use the forked version of Remix. The Solidity team in Parity, they forked the Remix IDE so that they could add this Revive compiler as the backend. So this Revive compiler, you can see the pathway. So here, like you have, let's say, an ERC20 Solidity contract. You want to compile it, right? So that you get the PVM blob at the end with the metadata so that you can deploy it on the chain, the Polkadot chain, let's say Asset Hub. Um, so how does this go about? Well, you'd create your smart contract on the Remix IDE, and then when you hit compile, it's actually going to use the original Sol-C compiler, and that's going to translate it to this UL format, which is this intermediate. It's a simpler format uh, that it's an intermediate representation of your smart contract. It's a simpler format that is easier for the Revive compiler to take and translate into the LLVM intermediate representation. From there, once we have the LLVM can optimize the code and emit a RISC-V ELF binary, right? So then we get that RISC-V version of the smart contract, and we from there we use a PolkaVM linker to actually get our PVM blob or PVM binary. Okay. So that's the process that it goes through, your Solidity smart contract goes through, so that at the end of the day, you can get that PVM binary along with the metadata so that you can deploy to your chain, right? So here's a diagram basically of like what I've been talking about. If you look here, make it larger, you can see like, let's say this is the Polkadot Asset Hub parachain, right? Where it's got the pallet revive and the ETH deployed on there. It's already deployed in the West End version of the Asset Hub. Um, so this is kind of the architecture, right? So you can see once you've compiled it in Remix, then you hit deploy right in Remix, right? Using MetaMask, and it'll deploy this PVM blob along with the metadata. It'll interact with the ETH server, right? And the ETH server, as we said, it repackages your transaction into something that Palette Revive can use, can read, right, through one of its extrinsics. And then finally, Palette Revive will store it in your runtime as a contract. So then in the future, if somebody wants to execute that contract via this ETH server, they can, right? So that's pretty much how it would work. And also, like if you want to work on this like locally, right? If you don't want to use the Asset Hub parachain, this is a palette. It's open source, Palette Revive and the ETH server. So you could build your own blockchain using the Substrate framework and integrate this palette, right? Palette Revive, and run it locally or deploy it on a test net, right? And have this PVM functionality so that you have Solidity on your chain. Okay, so that's the beauty of like, Substrate open source and all that is there. Okay, so that's about it. That's like the full flow. So let's look, like it's a lot of talking. Let me show you a demo. So let's see, let's pull up Remix. All right, so I got Remix, right? This is like Ethereum IDE. This is the forked version. So you can see in the URL, it's actually remix.polkadot.io. That's the one that you want to use for now, uh, because it's got that Revive compiler backend. So I'm going to click on contracts folder. There's a Solidity storage contract there. This is like a great hello world, contract storage, got number there. And you got two functions, right? One function is store, where it'll take a number as an argument and it'll store that number right there. And then you got another function to retrieve, and it'll retrieve the number that's in storage. Okay, pretty basic. So before I deploy this, like if you're new to this, you'd have to have the MetaMask wallet, right? And this is just test money here; it's not real money. So like I already have the West End Asset Hub network configured here. You'd have to configure that. So like you'd have to click on Add a custom network name, right? West End Asset Hub or Asset Hub, and then add the default RPC URL, the chain ID, currency symbol, and block explorer URL. And then once you add that, you'd be able to connect to the network so that you can deploy and transact, right? So if you want that information, you can actually go to contracts.polkadot.io. So everything that I'm going over is available in this tutorial here, as well as like some architectural stuff. So you can see here, here's the information, right? You'd plug that in. There's the RPC URL, right? Notice that it says West End Asset Hub ETH RPC, right? Okay, so that's all there for you. So that's what you'd plug in. So if once you have that in there, then we can use MetaMask to deploy. First, we need to compile. So I'm going to go here, Solidity compiler, and I'm going to say compile. All right, it compiled, right? Super little green check mark. Now let's deploy. And this is here. This is where you want to pick MetaMask, and it pulls my account. Looks like I have like 9.5 Win token. So you need some Win token. You'd have to go to the faucet, the West End faucet. It's faucet.polkadot.io. Select the network, the chain, and drop in the address here. So you can actually drop in your Ethereum address, right? Mine's right here. I just copied to the clipboard and paste it in there, right? And I could just say, uh, I'm not a robot, get some Win tokens and just wait for a second, and you'd get those tokens. I already have tokens, but I'll do it anyways just to show you. So let's see. Okay, green chart check mark. I mean, did I get it? Let's see. Yep, I got more. Wow, those win tokens are worth quite a bit, right? So, okay, so I got more tokens and I go back here. Yeah, I got more now, 19.5. And gas limit is estimated gas. So everything else is good. Let's deploy it. Click deploy. All right, there's my MetaMask confirm. And I'm just going to look down here, make this a little bit larger here. And it says creation of storage pending. So it's going to take a minute. One thing to note while that deploys, right? So behind the scenes, what is it doing, right? It's remix, right? It's submitting a transaction to the ETH RPC. Like that's why there was no need to like modify the remix source code in that sense, right? It just thinks it's deploying to Ethereum. So there it is. Okay, green check mark. All right, there's the block number. And actually, I mean, I don't know if it's too late. If I could see it here. Um, yeah, maybe actually. So right now I'm in the West End Asset Hub. I connected via the Polkadot.js UI. So I'm not connected to the ETH RPC server, right? Keep that in mind. I'm now connected here to the actual Asset Hub blockchain, right? So if we go back to the remix, it gave me a block number. Can I copy that? Let's see, copy. And I could actually just paste it in there. Oh, it is this one, 11.3.10.140. Yeah, it's this one. Okay, so we should see something in here. There we go. Look at that. Revive.eth transact, right? So that means that there was an extrinsic called eth transact that was called, right? Who called that? The proxy server, right? That we saw the source code. So that's pretty cool that we see the transaction there. All right. So it got deployed. So let's go back to Remix. And if I go down here, deployed contracts should be this one here. And let's test it, right? Let's say I want to store the number 887. Let's say some random number to store. So that's going to submit another transaction. Okay, MetaMask is coming up, confirm. And we're going to submit this transaction. So what is it doing, right? It's calling the store function, and we're storing the number 887. All right, so give that a second, and um, let's make sure that that executes on chain. So while that happens there, I just want to highlight that in the contracts.polkadot.io, like I said, everything that I discussed in the slide deck, it's here. So it's a great read. The other thing that's here that is nice is uh, additional information. So, like for example, differences to Ethereum, Substrate has a different way that it works with quote unquote gas. So once you get more involved with your smart contracts, Solidity smart contracts, you do want to read about this. You do want to become more familiar with Substrate. It's like a multi-dimensional way that it handles gas, slightly different than Ethereum. Okay, so it's really well described here. So that's another great reference for you to read. Okay, so let's go back. All right, green check mark. That's pretty cool. All right, so apparently it got stored. I'm sorry, yeah, well, the number got stored. The transaction succeeded and the number should have gotten stored. We can confirm that by calling retrieve, right? So let's call retrieve. We should get 887. And there it is, 887. Okay. So we just deployed a Solidity smart contract, PVM Solidity smart contract, and we interacted with the smart contract. All right. So this was an RPC call. That's why there was no transaction involved. So that's about it. If you go to this Polkadot.js UI, if I click on developer extrinsics, just to show you like this ETH transact, right? So these are all the palettes that are in Asset Hub West End. And there you see revive. And you can see these are all the extrinsics. Like these are, functions that are exposed to the outside world. One of them being ETH transact. So technically you could manually submit a payload by calling the pallet directly. I leave that for another day, but you don't need to do that, right? You can just interact with the EtherPC server. So if you want to look at the code, the functionality, which I really recommend, you can go to the Polkadot SDK. Let's see, Polkadot SDK frame revive, and you can actually click on source code for the palette revive, and there's excellent source code. Like, what do I mean by excellent source code? Well, first it's Rust. But second of all, it's super well documented. So like you can see, like you can read, what all the stuff does, right? Really great documentation. So for example, if I want to search, like let's function. So an extrinsic, I believe, is a public function. Yeah. So ETH. So here's a dispatchable, right? ETH transact, and you can actually read about it. If we go, there's other ones. There's the call, right? So there's a call dispatchable. On this level, we call it a dispatchable function. On on this level here, we call it an extrinsic. So what the outside world sees, these are extrinsics, right? And then from the programming aspect, these are what we call the dispatchable functions, right? It's kind of like it's one and the same thing, but just like nuances. Okay, so that's there. You can see, you can read it. It's really, really great read. All right, so that's all. I hope you've enjoyed the presentation, and I hope you understand why I recommend starting with Solidity on Polkadot and why now is the time, right? Now that we got PVM, it's hot and ready. Now is the great time to start with Solidity, especially as this the pre-compile starts getting merged in, right? The functionality starts going more into Asset Hub, so you can build more robust smart contracts from better, like more powerful, robust solutions. Um, Also a reminder that that there are grants available. There's the not only like you can apply to the Polkadot Treasury, but there's also the open source grant that's also available. It's open right now. Uh, you can submit, a project idea, technical project idea, and it goes up to 30K. There's also Web3 Foundation. They have grants. So if you have a good idea, you can hit the ground running. And also you're securing yourself by starting with Solidity on Polkadot, you're securing yourself with Jam, right? Because then the migration path, like you're already warmed up with Solidity and Polkadot, right? And then you can transition to Jam services once that's mature. All right. So thank you all. Happy hacking.